These are the exercises I will work through from lesson 1.3, which was function composition. The exercises come from this, OpenStax Precalculus 2E, and the link to the first page is here. And these are the ones you will see worked through in this video. So what I recommend is you try them first and then come back to the video where we go over the solutions. We begin number 11. We have F, we have G given. We want to do many things that involve composition. Maybe though, because note, here we're evaluating F composed G at 2, and here we're figuring out F composed G as a function. So if I do B first, it can only make my life easier. So let's do this. Let's do B first. What we want is F of G of X. So I put in 3x minus 5 where I see an x in the formula for F. We get to 3x minus 5 squared plus 1. Now, in our lecture video, we had a problem kind of like this, and I asked you to simplify. And the main reason was I wanted to make a point that F composed G and G composed F are typically not equal. Here, it doesn't say anything about simplifying, so I think I'll leave my answer like this. If you want to, you could multiply everything out. It's not a problem, but I will leave my answer like this in B. Let's move on to letter A. You see, once I have this function, I could just evaluate at 2. So F of G of 2, this is just 2 times 3 times 2 minus 5 squared plus 1. We get 2. This is 6 minus 5, which is 1. 2 times 1 squared plus 1 is 2 plus 1. This is 3. So I found that made my life slightly easier to do B before A. Now, letter C. Here we want G of F of X. So this would be G of 2x squared plus 1. So we put in 2x squared plus 1 in for the x in G of X. We get 3 times 2x squared plus 1 minus 5. And maybe here, I'm not squaring anything. All I need to do is just distribute a 3. Maybe here I will simplify. We get 6x squared plus 3 minus 5, which is 6x squared minus 2. Letter D, we want G composed G. Well, we didn't practice this in the lesson, but it's a wonderful exercise. So this means we put in G of X to G. My inside and outside function are both G. And so everywhere you see an X in the expression for G, we put in 3x minus 5. And just like above, I will simplify this sum. We get 9x minus 15 minus 5. Altogether, I have 9x minus 20. This is this, G composed G. Now the last one here I don't need function of x. I just need F composed F evaluated at minus 2. So I will do this in 2 steps. First, let's compute F of minus 2, and then I will evaluate F at that value. F of minus 2 is 2 minus 2 squared plus 1. Minus 2 squared is 4. Then we multiply by 2, and we get 8. 8 plus 1 is 9. Now we want F of 9. This will be my final answer. This is 2 times 9 squared plus 1. We get 81 times 2 plus 1, which is 163. So this is letter E. The answer is 163. This was number 11. Our next two examples, we want to find functions f and g such that the h of x can be expressed as f composed g. We did some examples of this in the lesson. Here are two more. Well, 38, I chose this problem because it's really moving us into lesson 1.4, which comes next, and that is the absolute value function. But for now, we don't have to worry about absolute value. I haven't talked about it in the lesson yet. We can still do this problem. You notice I have this inside function, and so I put g of x, my inside function, to be x squared plus 7. Now in your mind, replace all of g of x with an x. Read off what you have. We have f of x is the absolute value of x, and to be continued on what this function is and wonderful properties of this function. That's the next lesson. But for now, we have found f, we had found g such that f composed g equals h. Number 40. I mentioned in the lesson that you can have multiple answers. So we could find multiple functions or multiple pairs of functions f and g that satisfy f composed g equals h. And so I will give 3 possible solutions just because I'm trying to illustrate the point that it is not unique how you find an inside and outside function. So let me put 2 lines. We will do this 3 times. The first solution I will do kind of as it's handed to me. I see parentheses. And so let's let g of x be 1 over 2x minus 3. And then in our mind, we replace g of x with an x. Read off what we have. We have f of x is x squared. What else can we do? Well, you notice that h of x is this function. Right? We would square the numerator, square the denominator. And so another option, looking at it in this red highlighter, is I see g of x, or one possible g of x, is 2x minus 3. So let's try this. G of x is 2x minus 3. And then in our mind, we replace that with an x. Read off what we have. In this case, my f of x would be 1 over x squared. Once again, you can check f composed g gives us h. Now one more, although you could think of others, okay? But one more, and this comes up actually more than you think in Calculus 1, is I'm going to take my inside function to be the entire denominator. Comes up in Calculus 1, Calculus 2, for example. The entire denominator is my inside function. Let's take g of x to be 2x minus 3 squared. When I do this, well, if I replace, remember my h of x is this. Now replace 2x minus 3 squared with x. Like that. You see f of x is 1 over x. So I like this example in particular because it helps us realize that there's not just one answer when we look for an inside and an outside function. Here's our last few problems. These are really fun. We're using the graph to evaluate composite functions. This is fantastic. So, first, we need to look at the graph of g here. G of 1, well, here's the point on the graph. G of 1 is 3. So we want f of 3. Now we come over to graph f. And f of 3 is here. Maybe I should label these. So this is the point 1, 3. G of 1 is 3. And then we have the point 3, 2. We see f of 3 is 2. Next one, we want G compose f of 1. Well, this will be G of, well, what's f of 1? The point is here. The point on the graph of function f is 1, 3. And then okay, let's fill this in. We want G of 3 because f of 1 is 3. G of 3, well, 3, 4 is on the graph of G. So this point is 3, 4. And so G of 3 is 4. Now we have f compose f of 5. The first thing we need to do is evaluate f at 5. You notice f of 5 is 1, where the point 5, 1 is on the graph of f. So what we want is f of 1. Well, that is a point we have already used. In particular, we used it here, and I see 1, 3 is on the graph of f. F of 1 is 3. And so we have evaluated these composite functions by looking at graphs of the respective pieces. Thank you very much. These are the exercises from this lesson.